All right.
Let's think none.
All right. Very intriguing topics that we will not talk about at all.
What's your opinion on John Lennon?
On what?
On John Lennon.
John Lennon?
Let's get into it.
Well, if you only. Anyway. Unfortunately, a lot of people throughout history have had unfortunate opinions about certain topics. And some of them you can't distinguish it from some of the good stuff they've done, and some of them you can. And that's all I'll say. I'm not going to say which one John Lennon would fall into. This is the last I'm talking about this at all. Okay, any questions from homework? Yes.
Beethoven's bad.
This is the last.
I don't think.
What about Beethoven? We're talking about Beethoven now?
You got a question from homework?
Yeah,
There's going to be another John Lennon joke. I'm done.
Okay. Anything from homework for this class related to mathematics? Nothing. You guys are doing it, right? Okay. Okay. So we have one last section in chapter 4, and then we're done with that. This one's about linear inequalities. Oh shit. So, what does that mean?
These lines.
Lines, exactly. So if I were to graph this, how would I graph that? It's only a one variable, so it's going to be one dimension.
So it's the bracket?
No. Not interval notation, graph it.
Ah.
So, got a number line,
Yeah, so
got
it's
2. Okay, now you can say
bracketed
bracket.
thing, and then all the numbers, including 2, that are greater than 2.
We stop there, is it? Cool. And then you can do interval notation, all that kind of crap. Why, so what's the only point I put down there? 2. All right, let me overanalyze this because we're about to step into not just one variable, but 2 variables in a single inequality, right? 2 is the dividing point between answers and not answers. That is a really weird way to say it. Do you agree? But do you see how there's not answers and there's answers?
Yep.
So 2 is the dividing point in this case, because how do you cut a line in half at a point?
Or it's right, and or it's somewhat right.
Not in this case.
Okay.
Either you're right or you're wrong.
Yeah.
There's no nuance here, right? Is everybody with me?
Yes.
Okay. So what if I had this instead? So how did I know on this one to shade on this side? Because the things on this side work. There's shortcuts, of course. That's an arrow pointing you in the direction to shade it. You guys, I don't know if I ever actually said that in this class, but look at that arrow that way. Oh, that's the way I shade it. That's awesome.
How
All right.
Oh, I was just gonna say, I think your camera's off.
Poor little dude. Oh, he's on, is he? Yeah, he's on.
Is he?
I meant like off center.
Oh, off center. Between me and the camera, it's probably me that's off center. All right, there we go. Beep, boop. Okay. So this guy, look what this says. It says, I want all the y values that are bigger or equal to this. And what is this? If I were to graph that, what would it look like? Yeah, slope is 1. The y-piece, the y-intercept is 2. All right, so let's graph the line. Do the points on the line work? Yes, because the y is allowed to equal. All right, so here's the idea. Sort of like back in the day, you would have put a closed circle in that, right? Before you learned the better thing. So here, when I go to graph this line, what's up? You all right?
No, I keep forgetting that the X automatically has a 1, so you. Yeah.
Well, yeah, there's an understood 1.
Yeah.
Coolness. So how do I graph that?
0, 2.
0, 2. Thumbs up.
Up 1, over 1. up 1, over 1, up 1, over 1, and then I just make that big. Okay. Now, this is equivalent to the first step in this, is just identifying the dividing position. So how do I cut a plane in half? Like, how do I cut this piece of paper in half? I'd have to use a line, right? You can imagine, throw the paper up. Oh, samurai sword. You're right. And then, God, that was really easy, Jeff. Oh, too bad. Right, so I have to use a line to cut this plane, and one side is going to be all the answers, and the other side is going to be all the not answers. So before we look at that, can you guys give me points that would be answers? Like, if x was 0, what could y be to make this answer? Y must be bigger than or equal to x plus 2.
6.
2 would work, right? Or 6. 0, 6, because then isn't 6 bigger than 0 plus 2? What if x was negative 1?
1.
What's bigger than or equal to negative 1 plus 2? 1 would work. So you can make a bunch of these points, right? So how many points are on this line? Infinite number. But notice how not just the points on the line work, but so does, like, for example, 0, 6. 0, 6 works. You with me? All right, yes?
So half of infinity is the correct answer, and half of infinity is also the incorrect.
In a way. That's why I did like this, because there's half of infinity is actually infinity. That's how freaky infinity is.
Yeah.
But we know what we mean when we say that. Part of it, and then not, and the other part's not. So, what's really neat, now watch this. The same way that an entire side works, which means the entire other side doesn't, because it's a very directional idea. If I have 1 point, so for example, 0, 6 works, which means every point on that side works. Which means I would just shade that way. So the answer to one of these linear inequalities is going to be a region where all the points work. So if I plugged in, what point is this? 2, 0. If I plugged it into the inequality, what should happen? It won't work, because it's on the side of doesn't work. So let's try it. I'll plug a 2 in there and a 0, and there's 0 greater than or equal to 2 plus 2. Is that true?
No.
No. There you go. Okay. So this is called the test point method. You graph the line, and then you pick a point, plug it in, and see if it works. If it works, you shade in that direction. If it doesn't work, you shade in the other direction. Let's try another one from scratch. Turn this way. Okay. I think the only marker working right now is the blue one. Too bad. So here, let's try this one. Y less than negative x plus 3. What's the immediate difference between this one and that one in terms of inequality? True, there's a line. I don't care which way the line's going. What is the fundamental difference by the inequality?
Y is less than the...
Yeah.
Is it allowed to equal?
No.
No. Everybody with me? So back in the day, when I had a one-dimensional thing, I would put an open circle if it wasn't allowed to equal, right? So if it's allowed to equal, I make a shaded in line, a straight, full line. If it's not allowed to equal, I'm going to make it using a dotted line. It's kind of like our two-dimensional little bunch. Don't make a bunch of circles, just make a dotted line. That's the same thing as putting a parenthesis or an open circle on a one-dimensional thing. So it's kind of like we decide that's the easiest way to make a two-dimensional open circle, is to make it a dotted line. Okay. The points that are on the line, do they work? No, because the points on the line are where y equals this, and it's not allowed to equal this, is it?
It has to be less.
It's got to be less than. So I can't include the points on the line. No?
Sorry.
So, for example, if I plot this, x greater than 2, what am I going to put down here?
Parenthesis?
2. And then on the 2, I put what?
Parenthesis.
Parentheses.
Yeah.
I still have to indicate that 2 is the dividing point, but I'm not even including that point. I still got to put it though, don't I? So I've still got to graph this line, but I have to put the equivalent of a parenthesis, which we're going to use a dotted line. That means all the points on the line don't work. Because the points of the line make this equal. We want this to make sense. So if you want it, so for a friend, well, I guess it was a student of mine. I don't care about you people. He said, if you see a line, draw a line. If you don't see a line, make it dotted, right? So if you see a line, draw a line. I'm like, all right, I can deal with that.
That makes sense.
So I stole that from him like I steal most of what I teach. First semester I taught, I didn't say shit. I was just like, what are you going to say? Okay. Sounds good. All right, so let's see if one of these other ones are going to work. Dude, what do I know about this line? I like it. So 0, 3. Jeff, down 1, over 1, down 1, over.
Down 2, over.
And then the line I'm going to make is
Dotted.
dash, dotted, whatever your favorite way to say that.
Wouldn't dotted be counterproductive?
Dash it?
Dodged it.
Dash it?
Dodged it.
Wouldn't dotted be a little bit counterproductive towards points a little bit?
Would dotted be counterproductive?
Because like dotted would be like dots.
Oh, I got you. I got you.
That's where people do
Didn't
that.
say
Just
dash.
draw little dashes between the points.
Little dashes.
Yeah, little dashes between the points that show up, just so it's clear.
I like. So do what now? What's wrong with this?
Well, no, I'm just saying like the way I did it here is just to make sure it's a dotted line. So between each of those like big circle points, just draw one little dash.
Oh,
in
okay,
between them.
cool.
Yeah.
Whatever
It's
you got to
just-
do
it's
to
just-
make
it's
sure
just
I
another
know
way.
that it's dotted, dashed, whatever way you want to say it. No matter what kind of line it is, you have to determine which side. The answer is truly the shading. The same way as a two-dimensional thing, right? This isn't really done until I shade that bad boy in. So, what do you think is the best point to use? 0, 0. You can use whatever point you want to, as long as it isn't on the line. Because you got to determine which side works. And if it's on the line, with the shit, that's not helping you out. So if I do plug in 0, 0, why is it the best? Because it just makes these 0. It's quick. 0 less than 3, right? See how I can go straight to there? Is that true?
Yeah.
Yeah.
Yeah. So what side did that work? This one. So that's the side that works. Yes.
So if we do this like on graph paper or homework, do you want us to shade like fill it in or shade like that?
I'm trying to get you guys used to this.
Okay, cool.
Because eventually we're going to do where we have 2 lines at once.
Yeah, and that's easier.
And then the answer is going to be where the shading overlaps. And if you do this shit, it gets really. And I love my people that have the colored pencils and stuff. That's like, I would never do that. But I love it. That's awesome. My anal retentive people do it. So what's true about that point?
If it's that.
It wouldn't work. I like it. So, I'm not going to make this into a problem to do, but I want to show you where this kind of thing leads. So you could have an electrical circuit, and if you put too much current on it, things are going to blow up. Or if you put, what do I want to say? If you make it too long, it's going to be bad. All these kind of restrictions. So if you graph the restrictions for each situation, and so like if I graph this one means too much current, this one means too long, this one means something else, I end up with like a little safe zone. So a lot of the dials that have like red zones and white and yellow zones, you know what I mean? They're kind of creeping up towards the red. And they kind of look at one thing at a time. You could actually create this like safe zone. So you could have something that takes a measurement and it says we're currently right there. Oh shit, let's go do something about that because that's not in the safe zone. I don't know if you guys really, that's what this kind of mathematics leads up to, is if I have several conditions, like the maximum load in an elevator is this many people and so forth. But if I graph all of them, I can see what my safe zone is. And if I have a way to measure those things, I can tell if I'm in there or not. If I'm not, that's when the little dial goes into the red. And then I get off my ass and go, holy shit, what's going on? Okay, maybe, a little bit, okay. So, let me see, what about this here? What you got, Jeff? You can do it, buddy. There you go, man. Now, there are a couple different ways to do this, but I try to steer you in a direction because you got to get used to mx plus b and how it helps you. So understanding what I just said, what should be the first thing I do? Solve for y, right? And now you're telling me details of how to do that. First thing I want to do is solve for y. So I do what now?
If you want to make the 3y positive, you could.
Yeah, you could always switch these. I got you. But let's do it this way. I think this is the way most people will think about it. That's the way I would do it, by the way. Oh, real quick. I've done this a few times already. Why am I putting that, why am I forcing it in front?
For fun.
Totally.
MX plus B.
But it also happens to be mx plus b4, right?
Yeah.
In the homework, I've got a few people that there's a problem like this, and they tell me the slope is 4 and the y-intercept is 0, negative 1/3. Is that correct?
Yeah.
Why? mx plus b, the slope is the number in front of the, even if it's out of order. Of course I can always take it and just move them around. I don't suddenly change the slope of the line just because I wrote it in a different order. That's freaky. Bless you. A little insight into young Jeff. I used to think that if you wrote the equations of the universe down and then switched them around, shit would change in the universe. I was
I think the thing you could also say is that because there's no x behind the 4, it wouldn't be right because
that's the same thing. So the number in front of the x is the slope.
Yeah.
So the slope is actually what?
Negative.
Negative 1/3.
Yeah.
And the y-intercept would be what? 4.
Yes.
0, 4. I like it. Just because it's out of order doesn't suddenly change what the line looks like. That's a little more than that's able to do. It's just an equation. All right, just like young Jeff learned. Yeah, and then you divide by. Now, here's where you got to remember what? Flip it.
Negative 4.
Why you gotta flip the sign?
Yeah, Jeff, remind me why we flipped the sign?
All right, I'll remind you.
Please.
Actually, here's the interesting thing. The way you suggested I do it, it would have taken the y to the other side. So if you read it this way, it would have been y less than, well, now it is. So one way to look at it is it makes it match with the way if you would have went that way. That is not satisfactory, though. It's kind of like math shouldn't do that. Oh, shit, I better make it work. No. So remember, here's why. Which one of these is bigger?
2.
If I divide by negative 1, which one is bigger now?
The 1.
What happened? Yeah, so if you divide or multiply both sides of an inequality, it's got to switch. Because when you divide or multiply by negative, you change what side of 0 you're on. So whatever was bigger is now smaller. Whatever was smaller is now bigger.
But if it's
Yes.
positive, then you just leave it.
Oh yeah, so if I don't multiply or divide both sides by negative, then I leave it alone. So like for example, that's true, right?
Mm-hmm.
If I add 1 to both sides, it's got to stay true, and does it? Yes. Right. But if I divide by a negative, you can see it just has to switch to stay true. So why does it switch? Because I love it. That's the one time I can say that. Just because that's what numbers do. Next. Okay, maybe. No? Yes? No?
Maybe.
All right. Graph that. If you haven't started already, go ahead and graph that. As long as you can see, it looks like the y-intercept is -5 though. I'm still not sure where the 3 and the 4. Oh, I guess, yeah, so they actually gave you the equation. See, from the graph, it looks like it's -5, but they gave you the equation. So the y, yeah, so it's strictly less than because it's dotted, and it's less than because it's shaded down.
So what about this?
Graph it. Yeah, so one way is starting with the graph and going back to this, and now you're starting with this and making. Just graph it. Yeah. Of course, if it's given to you, all of these are solved for x. Oh, no, like this. Gotta solve for y. All right, let me catch up to you guys. See if purple's working. Ooh. So what do you know about this thing?
The y-intercept is 0, -4.
Y-intercept is 0, -4. I like it.
Goes up to
To
the right 3.
over 3. All right there. Make that bigger. Yay. And why did I make it a solid line? Sort of skips that though. Because you see a line, so you're allowed to equal it, so you shade it in.
See line say.
Now if you,
You're gonna shade it from left side.
oh! All right. Now, let's do it the way we just did it, and then I'll give you the way that I do it. I don't do it with the test point, but if you do a test point, is 0 less than or equal to 0 minus 4? Is 0 less than or equal to -4? So when I plug 0, 0 in, does it work?
No.
No. That point did not work, so where do I shade?
Below.
Below. You guys all right over there? Scheisse. You got a 50-50 shot.
I forgot to flip this.
Now, guys, that way always works. The only time you can't use 0, 0 is if the line itself goes through 0, 0. Then you would use like 1, 0 or 0, 1 or 1, 1.
Or 18, 20.
13 common square root of 7 if you want to. I doubt. I don't want to do that shit. That'd be weird if you did. Watch this. Another way to look at this. What does this line say the answer should be? It should be all the y's that are below or equal to that are below this line. Right? Once I make the solid line take care of this. Below this line, that's why it's down here. Where's the y less than the line here? This way. So less than, I'm going to shade down. The reason that gets a little weird is when my line gets really steep, up and down is weird. It's like there's no up and down. Like where's up and down here? That's up and that's down, but it's really kind of weird to look at. Test point always works. But if I see less than and it's kind of like low enough, then it's easy to tell what's up and down. Less than, down. Greater than, up. No, yes, maybe, yes.
What if it's just like an x value, so it's just like a straight up and down line?
Oh, okay. Let's do one of those. So our two special cases. And I would have to say in the instructions somehow, or I'd give you an XY plane, or I'd say graph on an XY plane. Because if I just have one letter in the problem, I shouldn't need 2 dimensions. But if I did say graph this on an XY plane, x greater than -1, what does x equal to -1 look like? That's what I graph first. A straight line going which way? Vertical.
Oh, yeah.
Right? Because x has to be -1, so it can't go left and right. It can only go up and down. Does everybody see that?
Mhm.
So really the first step is to graph, replace that with an equal sign. That's what we've basically been doing, graph that line, and then shade. Now what kind of line is it going to be though? Dotted. So right here. Weehaw. And then it's easy. Isn't it easy? X greater than, where are the x's bigger? Holy shit, yeah, that way.
You can just shift your paper and turn it with the right and do the same.
Whatever works. Now let's see if you get this. That was weird. If I just said graph this on a number line, it would just be this, right? Yeah. When I introduce this, it doesn't give a shit what y is. So for every value of y, I've got that. So right here I've got that, right here I've got that, right here I've got that. So it just all makes this half plane. So incredibly enough, if I said y is greater than or equal to 2, what's that going to look like?
And a straight horizontal line. And then
anything above.
Yeah.
Oh, so this is
That is the region where the y's are bigger than 2. Or equal. Yes. What's the matter? Oh yeah, neato. So now the real big key is, can you tell if it's going to be greater or less than, right?
Yeah.
So I would say solve this for y, and then it's easier, because then it would be greater than. Yep. All right, so let me give you this. Let's see. This, I think, is out of the blue book, but it's like section 8. I don't remember. Let's see, it's up. Maybe.
Just have to.
I think this is, I can't remember where this is in there. So don't try to find it, just use this. So ragtag team over there. It's like spread out all over the map. All right, let's look at the front of this sucker together. Get in there. Rah. Okay. No input. Inputs happen. Okay. So this sucker wakes up. Real quick, you guys, what's here? I was gonna say, do you guys know what happened this morning politically?
Pelosi.
Well, no, that's a woman.
that was yes.
They interrogated the intelligence, the head of intelligence, about Trump's Ukrainian phone call. Have you guys heard anything about this? So notice how I'm not saying how I feel about it. I tried to escalate my politics out, but you should desperately be sort of aware, at least, of what's happening. Independent of how you feel about it, you should know what's going on. So anyway, so.
Okay, so what was his back
So what
story then? Like what happened?
The,
Yeah,
where's the guys? Haven't heard anything about it at all?
Yeah, where's the
No.
beef, dude?
So there was a whistleblower complaint related to a phone call Trump had with the Ukrainian president. Yeah, the Ukrainian president. And apparently, and they released the transcripts, which are really kind of hilarious because they released not the full transcripts, but what they released, I can't help but show my political stripes. What they released was still damning because it showed that a few weeks before this phone call, they withheld aid to the Ukraine that the Congress had said give it to them. And on the phone call, Trump said, "We've been helping you out really well, but we need you to help us out and investigate these ties that Biden has with some companies in Ukraine so that maybe I could use it in the election." Yeah. So, personally, I should turn them off. But I'm
You can
not
edit it out.
indoctrinating you. You guys can disagree with me. That's great. But before this phone call, we had plenty of evidence that at least warranted a look. But with this phone call, it finally pushed some people over the edge and said, yes, we need to start an impeachment inquiry, right? Anyway, so this is very interesting times we live in. No matter how you feel one way or the other, you should be keeping up with the facts of the case. All right.
Oh, what happened?
So right now, so this morning they discussed this with the head of intelligence, and he was kind of in charge of making a decision about whether or not this should be forwarded to Congress. And supposedly the law says it needs to be automatic, that they give a whistleblower complaint to Congress so they can see what's in there. And that was withheld. So this is all about why did that happen, were you coerced to do this, and all this kind of stuff, right? So anyway, some of you guys are like, oh, I don't want to know about this. So part of me kind of feels, if you've been out of the picture with this, I'm like, wow, man, that sounds awesome. I would love to not know any of this shit. But, you know, sorry. So at the same time, you really should be aware, because this is kind of huge. This is what people are going to be.
It never happened in Nixon.
20 years from now, they're going to have this stuff in the history books, and possibly your kids are going to be learning about this. You can be like, oh yeah, I heard, you know, some math teacher said some shit. But maybe you should also be very aware of what's happening, because the last time that a president was impeached was Clinton, and that was, of course, some of you guys weren't alive then, but you might know Cigar was involved. Anyway, that's all we'll talk about.
6.
So he wasn't thrown out of office. Impeachment just means you go through the trial, the whole process. So it ended with him not being thrown out of office. So we'll see what happens. I don't know anymore.
I feel old.
They'll just buy their way through all of that.
What's that?
They buy their way.
26.
Yeah. All right. Sorry guys, that's a little much, but you know. Not related to math, but still, you guys should be aware of what's happening because it affects your futures. So let's take a look here. So we sort of did this part already up here. Can somebody tell me a solution to this?
0 and 1.
Yeah, 0 and 1. 0 plus 1 is definitely less than 2.